Hi, well, as you can see, I'm not in my usual production space. I am working on a brand new space here in the garage. Right underneath the camera here, I have a whole new workbench that I'm working on. It's so that I can get more content to you, new types of content to you, and what has been a rather sparse summer. The video that you're about to see is one that I originally produced back in April. The results weren't exactly what I expected or what I was hoping to get, and so I kind of shelved it. Didn't know what I was going to do with it. With the lack of content here, I took another look at it, decided, you know what, this wasn't bad content. The things I talk about are still good. The methodologies are still good. So here it is, an unpublished video from back in April. It's still relevant to the Cosplay 600 printer I've been building, and I really hope you enjoy it. Please stay tuned to the end where I'm actually going to talk about the current plans for the Cosplay 600, since the closing of the video is probably a little old compared to where I am today. Thanks for watching.
So in my last video, I replaced the belt in my Cosplay 600 printer with a ball screw. From that video, I got lots of feedback, lots of ideas, and so because of that, I have lots of upgrades coming to this printer. In this video though, I tackle one of sort of the easiest ones to take on, which is getting the most out of my NEMA 17 motor, and can I get enough juice out of that motor to power this printer with the ball screw. So what I've got three different stepper drivers. I've got a Toshiba TB67 S109, which will give me a full 4 amps of power to the motors. I also have the traditional TMC2208, and I've got an A4988, which all give me slightly different powers and different curves and sine waves to these motors for driving. So what I'm going to do in this video, I'm going to test these out. I'm going to try to get the most out of this motor and find out how fast can I go with the ball screw on this 3D printer here on Kersey Fabrications. Let's go. So as I mentioned in the previous video, I had lots of feedback, and one of the things I saw several times and I thought was fairly easy to tackle for this before I went any further was to make sure that I got the most out of the NEMA 17 motor that was driving that ball screw. So because of that, a lot of people commented, hey, you've got a 2 amp or a 2.1 amp motor, and the stepper drivers you're using can't actually power that much of a motor. They were absolutely correct on that. So what I've done is I've gone and I've grabbed 3 different stepper drivers to see can I get the most out of this motor. So I've got 3 drivers here. I've got the one that's already in the printer, which is a TMC2208 on spread cycle mode. And on that spread cycle mode, I should be able to get about 1.4 amps to the motor. I also have an A4988, which I believe I can get about 2 amps to using that driver, but according to the specs in the data sheet, that's greatly affected on heat. So I'm not exactly sure how that's going to work for that driver. And then as a last ditch effort, I have a brand new driver. I couldn't find any videos on this one. If you know of one, please leave a comment down below. I'll take a look. But this new stepper driver is a Toshiba TB67 S109, S109 for short. This one will provide a full 4 amps of power to the stepper driver. More than we're going to need, obviously, but using the calculations I found in the data sheets for this stepper stick, I was able to figure out how to get the full 2 amps or 2.1 amps to the motors that I've got here behind me. So I'm going to start out with the TMC2208 because that's what's already in here. So I read the data sheet for that stepper driver. It was a little confusing. So in one section it said not to exceed 1 volt reference for that driver, but yet if you look at the math section, the math says that it's the VREF times 0.71 will give you the current going to that motor. So I went up to a full 2 volts for this one, which I believe will give the 1.4 amps that it's spec'd to deliver to the motor. So I've got the electronics enclosure behind me. Take off the fan here, which is keeping everything cool. And I'm going to show you how we set the voltages on these stepper drivers, and then we'll run some tests on the printer. So here's the electronics on my Cosplay 600. This is an MKS Gen V 1.4 main board. And here on the Y-axis, you'll see the TMC2208 stepper stick. And I can test the reference voltage on this particular stick, and almost all of the sticks, by taking my black lead to ground, and then taking my red lead to the actual screw that you use to adjust the voltage. And on this one, you see I've almost got this one running at 2 volts, which, like I said, according to the data sheet, I believe will give me 1.4 amps out to the motor. So what I'm going to do now is I have actually sliced a 200%, or excuse me, I've actually sliced a 400% size XYZ cube. And I'm going to run this printer in what's called dry run mode. What I want to see is, with the settings that I've got on the slicer right now, which is 1,000 millimeters per second squared acceleration for both print and travel, and 100 millimeters per second for all of my print speeds, and 150 millimeters per second for my travel speed, can this ball screw keep up with this stepper driver? We'll also probably take some measurements of the temperature of both the stepper driver after a little bit, as well as the stepper motor itself, to see if we have any heating issues. But that really just depends on how far we get with the test. So I'm going to go ahead and begin this print. Again, this is in dry run mode, so we won't get any extrusions. We're just going to test speed here. And this dry run mode is brought to you by Octoprint. It's built in. So what we're looking for here is the first time that it actually skips, that we actually hear it sort of scream at us because it misses some steps. So far so good. It's handling the 1,000 millimeters per second squared on the acceleration. Handling the 100 millimeter per second actual print speed. But on this is actually doing a brim right now, and there are sort of soft corners that it's taking. It's not taking any hard turns. Here it's actually to the cube. It is done with the brim. Yep, and that was the first skip. And there's a lot of skipping. So at this point we're running the 1.4 amps. It doesn't seem to be able to handle what we've thrown at it. But it actually handled it better than I thought it would. So let's take some measurements of the temperature. So the temperature of the motor, which hasn't been running very long, is about 30 C or so. Not bad at all. And the temperature of the driver, which is being cooled by the large 120 millimeter fan, is also only about 31 C. So without much print time on us, we actually are doing great on temperatures. I'll let it run here for another few minutes to see how the temperatures creep up running at this level. One of my goals here is not necessarily to be able to print at this speed, which would be wonderful if I could, but it's also to have some overhead. So if I want to print slower, I don't want to be printing at my maximum speed, I need to at least be able to print a good bit faster than what I want to. So those 150 millimeter travels are important for the overall speed. And it's probably going to skip here again as it travels. Yeah. So anytime we try to accelerate up to that 150 millimeters per second, it is really dying on us. I'm going to do one more check of the temperature now that we've gone a full layer and see if anything's changed. So motor still holding pretty steady right around 30 C. 2208 stepper. Actually running cooler now. Actually about running the same, 30 C or so, a little bit cooler. So definitely the driver and motor not having any problems running at this current, but not able to meet what I was aiming for. So at this point, I'm going to shut this print down, and then we will go ahead and shut everything down and actually put in the new stepper driver, change some jumpers, and we'll be ready to run the next test. All right, here we are. We're going to switch out the stepper drivers. Pull off the cover, and I'm going to pull off the Y-axis stepper. And the first thing we need to do when we're trading out steppers is switch over the jumpers. So for the 2208, it should have been, yeah, it's all low. For the 4988, which we're going to do next, we are going to high, high, low, because we're doing 1/8 stepping. All right, now we can stick in the new stepper driver. And then if everything worked right, we can cut on the printer. And back on our cover for cooling. Actually, we'll need to set our voltage first. So computed the correct voltage, which is VREF over 0.4. With this driver, we can do a max of 2 amps. So for this one, that means we can do a 1.1 VREF. And that's also calculating in that each of the coils can only get 0.7 of the total current. So cutting this on, we have 9.76. So we can go a little bit higher on this one. Turn it up a little bit. And let's try it one more time. We take baby steps when we're doing these. That is 1.097. So that's great for what we were going for. And we also need to verify our steps. So backing off here, make sure that the printer homes correctly, and that will let us know whether we have the steps set correctly. If we end up in the middle of the bed, everything is set correct. Oh. So this is a problem. As you switch around the direction of these stepper sticks, you'll find that sometimes the direction of the sticks actually change. So I've got this here where I can actually switch. Let me go closer. So if you find out it's the direction's backwards, you can swap the cable. So I've got this flat connector on this. I can swap it around, and that will switch the direction of the stepper without having to change any firmware. Now that we have the direction hopefully correct, we're actually going to home this again, see if we have the steps correct. It's looking like it's the right speed. But as long as it ends up correct in the Y direction, we're good. And that does look about the center of the bed. So since we're home correctly, we're going to run the same G code we ran before and see how this driver does. All right, just like before, we have everything powered up, ready to go. We are going to load up the calibration cube. And we're going to do a dry run print to see how this printer does with this driver. Same settings as last time. We're looking to see if it skips at all during the dry run print. So this stepper driver should be giving us a full 2 amps to the motor. And as you saw, it just skipped. Let's see if it does it again. We'll also check temperatures and stuff here in a minute as well. I'm going to have to be ready to stop this if it skips in the wrong direction again. Otherwise, it's going to slam the screw or the bed into the mount. So I had one skip early on. So far, I haven't seen another one. There it goes. So we got another one. Really no reason to keep going since it has failed the test. I will let it go a little bit longer and we'll check some temperatures. The motor at this point is running. Still running cool, about 29C. See how the stepper's doing. Taking the cover off. And this stepper is running at about 31C still. So the cooling's doing fine. Everything still seems like it's running in spec. I expect to skip here. See if we get it. There it goes. So this one, even though we're supposedly driving more current to the stepper driver, it is not even doing as well as the previous one. And that may have to do with the way that it actually drives that stepper. So I'm going to check temperature one more time, see how it's holding up. Stepper motor still running at 30C, and stepper driver is running at about 32C. It's a little hotter than the last one, but definitely no problem. So let's go and stop this print, and then we will try our last driver and see how we do. Okay, so on to the last steppers. We'll pull out the 4988 stepper we just ran and replace it with the beefy new stepper. Big heat sink on this one, and a lot of large components on this one as well. For the 1/8 stepping for this one, need to set it to high, low, high on these. I'm just going to move one of the jumpers. That should give us 1/8 stepping. And then according to the orientation, that should be down, and we should be ready to go. So cut this back on, we'll have to check the step direction again, or the motor direction. Actually, first things first, we need to check the voltage. Because on this one, it says that it's VREF times 2. We want 2 amps out of it. So let's get in here and do ground, and where we're at by default, and we're at 0.781. We need to increase that to try to get 1 out of it. Without shorting anything out. Try to the right and see if that's the right direction. Sometimes you're not sure which way these go. Let's see. Is that the right direction, or is it the other way? So that went down, so it's going to be to the left to increase the voltage on this one. If you have some alligator clips, you can actually do this as you go. But since not everyone's going to have that, I thought I'd show this method. It's a little bit more time consuming, but it works. So now we're at 0.993, which is good enough for what we're doing. All right, it's going to get hot. Get our fan back on. Okay, we're going to do an auto home to see if it goes in the right direction. Be ready in case it goes backwards. Nope, that's right this time. And the steps look correct. We'll make sure it goes back to the center. All right, now it's time for a test print. Same settings as the last print. So, right at the change to the bottom layer cross sections, we get the same squeal as we were getting before. This is the 48 millimeter 2 amp stepper motor that we were using on this. I was impressed. We got pretty far before it squealed on us that time. Next up, we'll see if this squeals on us one more time. I'll also check the temperatures on everything like we did with the previous ones. So at this point, the motor is running at 33C, and the stepper is running at about 31C. So still no extra heat here. Got some overhead still. So let's go back to the 2208 because it was a lot quieter, seemed to be working just as well. And using that driver, is it the speed or is it the acceleration that's really killing us? Can we turn either one down and get better performance? Let's switch over. So for this next print, I'm using back to the TCM2208, running at 1.4 amps, which is the max for this, and I've used the same G-code, but I've turned down the acceleration to 500 millimeters per second squared for both the print and travel, and all of my speeds are still at 100 millimeters per second, travel at 150. Let's see if this works. All right, final test. Since we've seen this one skip once, I'm stopping it here. I'm going to put the acceleration back, but turn down the speeds, all of them to 100, and see if we can run with the acceleration still at 1,000. And if this one fails, we're back to where we started. I think something needs greasing because this is as noisy as it's been. So after all that, a night of testing, not a bit of difference in what this printer can actually do tonight. Seems I've about maxed out what the NEMA 17s can do, even with extra current, extra power to the motor. So, you know, I would say that, you know, this was my first time messing with the S109s. I would say that overall, in terms of the sounds they make, in terms of the technology, that if you look at the spec sheets, it's a PWM based stepper driver. It's very similar to the A4988, and I think basically all you're getting out of it is some extra current. So at this point, it sounds like I am stuck with the NEMA 17s being able to accomplish about 100 millimeters per second at a 500 millimeter per second squared acceleration. That's about all I'm going to be able to get out of this in its current configuration. Good thing about the S109s is they should be able to power everything. I think the spec sheet said something up to like a NEMA 50 something. So, you know, that gives you a lot of room for expansion. Any of these motors that require 4 amps, they'll be able to power, which means I can test a NEMA 23 at some point. For now, I'm done with the ball screw. I'm going to keep with the performance I have, and I'm probably going to move now to a big upgrade I've got. I've got a change in design for the X-axis. It's going to make it more rigid, and also I'm going to be switching out the extruder to a direct drive. But I'm going to do all that at the same time. That's going to be my next video. I'll see you guys next time. Again, if you haven't subscribed, please do so. I've got more of these videos coming out. I actually do have some other content I'm going to put out. Some cosplay. I got some Iron Man stuff that I've got coming directly. I've got some tutorials about prop making that's coming up next as well. Besides that, again, leave me a comment. Tell me what you'd like to see in this channel. And if this is your first time, welcome, and I appreciate you joining me here on Kersey Fabrications.
So with all that said and done, where am I actually on the Cosplay 600? Well, where it is today, I've got all the motion working, the printer's working fine, the new direct drive that you may have seen in a previous live stream, which I'll link up here, is all doing well. The print quality that I've seen out of it has been real good also. Biggest problem right now is I still can't get the TMC2208 running in silent step mode, and so that's actually keeping it too loud to run in the house. So I've got one more thing I want to do to the printer. I'm going to be converting it from 12 volt to 24 volt. I've got all of my parts to do that. I want to do a video in case you've never seen how to convert a printer. I'm going to do a video showing how that works. And then we're going to see kind of where the Cosplay 600 is at that point. Is it going to be a noisy printer that needs to be in a shop, or will it be something that you can actually run in a living room or in a bedroom? And that's kind of what I'm working on as goal number one right now. So from here, if you haven't seen the live stream from, I guess at this point, a couple months ago, I'm going to include a link in the description as well as one in one of these corners here so that you can follow. I hope you enjoyed this video. I'm going to have more about the Cosplay 600. I've got a lot more Ender 5 stuff, so thanks for joining me. I'm Chris. This has been Kersey Fabrications.